This lesson is on solving a system of equations by substitution. And in the past, you have probably learned to solve systems of equations where there are two equations and two unknowns, as we see here, by graphing these two equations and then finding the point of intersection, which is the solution. And the graphing method is limited because, first of all, you have to be good at drawing and make an accurate graph of the two equations. And secondly, it's very difficult to get solutions where one of the, or more of the coordinates, for example, is a fraction. So it's really hard to eyeball an answer like 3/16. So we're going to learn a more systematic algebraic method, which this method is the substitution method. So we have our system here. We're going to work through the procedure with each of these equations, and we can see here it says the first step is to isolate one variable in one equation, and in the first equation we have 2x plus 2y is equal to 7. And these two terms, 2x and 2y, each have coefficients of 2 in front of the variable. And so if we wanted to isolate that variable, for example, to isolate the x, we would subtract off the y, but then we would have to divide by 2 and get a fraction of 7/2. And that's not ideal. So what we want to do is choose the best variable, which in this case is the x in the second equation, because there's no coefficient here. So if we were to isolate that x, we would just subtract off the 4y. So we're going to go ahead and solve for x. We've got x is equal to, and then adding 4y to both sides, we end up with positive 4y on the right, and then plus 1. And now what that allows us to do is to use this expression of 4y plus 1 as a substitute for the x. So we're going to go to step 2, which says substitute that variable into the other equation. So in our first equation, we have 2x plus 2y equals 7, but instead of x, we're going to write in 4y plus 1. And then we'll continue with the equation, rewriting it. We have plus 2y is equal to 7. And now you can see we have a single equation with the single variable y in here, so we can go ahead and solve for that y, which is step 3. So distributing here, we get 2 times 4y gives us 8y, and again multiplying the 2 times the second term, we end up with plus 2, and then finishing off the equation, we've got plus 2y is equal to 7. And so then continuing to solve, we'll put our two y terms together, and we have 8y plus 2y is equal to 10y, plus 2 is equal to 7, and isolating the y, we'll subtract off 2. We have 10y is equal to 7 minus 2 gives us 5, and finally, the last step in isolating the y, we're going to divide by 10 on both sides of the equation. So we end up then that y is equal to 5/10, which we can reduce to 1/2. And that feels really good. It feels like we've got a solution here, but actually we've only got half the solution because since we have two coordinates, x and y, we have to find values for both of those coordinates. So now we have to go back to step 4, which says solve for the other variable. So we want to solve for the x, and we'll do that by plugging y is equal to 1/2 into an equation. And we could choose one of the original two equations, but actually, because we already isolated the x over here, we might as well use that equation and plug in y into the equation where x is isolated. So we've got x is equal to 4 times, and then y we said is 1/2 plus 1. So simplifying here, 4 times 1/2 gives us 2, plus 1 is equal to 3, and that is our value of x. So now that we have both coordinates, we can go back and write the ordered pair for this. So we can say x is equal to 3 and y is equal to 1/2. And that's our solution. Step 5 says that we can check both equations. So we'll take this solution that we found, 3, 1/2, and we'll plug it into each of the two equations. So for the first equation, we have 2x. So we're doing our checking here. So again, for the first equation, we've got 2 times x, which is 3, plus 2 times y, which is a half. And is that equal to 7? We're not sure about that, so I'm going to put a question mark there. But when we simplify it, 2 times 3 gives us 6, plus 2 times a half is 1, and that is equal to 7. And so we know that this gives a true equation for the first equation. And now we're going to check the second equation and see whether this also gives a true equation. So we have x minus 4y, so for x we plug in 3, minus 4y, so that's 4 times parentheses 1 half, we're multiplying here, and is that equal to 1? And again, we're not sure yet, but we can simplify and we end up with 3 minus 4 times a half gives us a 2, and that is equal to 1, so that also checks, and we feel confident then that our solution of 3 1/2 is a good solution.